film will first show what the Navy is planning for the offensive employment of biological and chemical warfare. Biological and chemical warfare have two principal objectives: to reduce the enemy's production of food by destroying his crops and his food-producing farm animals, and to incapacitate the enemy's armed forces and that portion of his human population that directly supports them. The Navy is preparing to accomplish these objectives with both biological and chemical agents. The Department of Defense has assigned primary responsibility to the Chemical Corps, U.S. Army, for basic research in biological and chemical agents and for their production in the quantities needed by the joint services. The Navy, therefore, is primarily concerned with delivery of these agents to the areas ordered for contamination, and the dispersion of the agents in such form and concentration as to accomplish the desired objectives. Where can the Navy attack? As long as the Navy commands the seas, it can deliver a biological or chemical attack anywhere on that 3/4 of the Earth's surface that's covered by water. And its carrier-based aircraft can strike hundreds of miles inland from any coastline and attack a large portion of an enemy's population, shipping, and industrial centers. The Navy can deliver and disperse these agents in 3 ways: from the air, from the surface, and from below the surface. Navy delivery and dispersion of the agents started with tests made in 1950. A rather crude spraying system was installed on a mine layer, which in September of that year secretly cruised off California and sprayed some 50 gallons of biological simulant along a track 2 to 5 miles offshore. Within an hour, the simulant had been carried ashore by the wind. Sampling tests indicated that about 48 square miles of heavily populated area were contaminated. Had an infectious agent been used in the spray, there might have been 210,000 casualties. With that experiment successful, the southeast coast of the United States was selected for a larger scale test. The rather flat terrain would be favorable to wide dispersion of wind-borne particles. But wide dispersion, of course, would depend upon the existence of the proper weather conditions. After extensive studies, it was determined that a track along here, from 5 to 15 miles offshore, should do the job. Accordingly, in April 1952, the USS Tercel cruised along some 100 miles of coastline, spraying 250 pounds of fluorescent tracer particles. The operation lasted about 8 hours. Sampling tests made throughout North Carolina, South Carolina, and Georgia indicated that an area of some 20,000 square miles received these particles, proving that it is possible to contaminate extremely large land areas by releasing sprays at sea under the proper weather conditions. In an actual attack, the spray would be released from either a submarine submerged to periscope depth or from an aircraft cruising at low altitude. A submarine operation experimenting with mines has been carried out, which is significant in this type of warfare. The mine used was similar to the Mark 10-3, which the submarine service is accustomed to planting. The mine provided spaces for biological simulant and compressed air. It also incorporated timing devices for releasing the mine from its mooring and for starting the spraying action. Trials were held at Key West, Florida in April 1952. 7 of these mines were laid. The trials demonstrated that the Navy has a powerful offensive weapon for biological warfare. Here are the principles involved. As the submarine approaches a coastal area target, it lays these mines filled with biological agents. The mines sink to the bottom and remain inactive for a predetermined time while the submarine escapes. Then, at a preset time, the main portion of each mine detaches itself from the mooring part, rises to the surface, and sprays its contents into the air to be carried ashore by the wind. The Key West trials show the feasibility of using this type of mine for contaminating coastal areas. And inland areas can be brought under biological attack by laying similar mines from aircraft in bays and inland waterways. Other tests have been conducted to determine the best application of this type of warfare in an amphibious operation. A spray tank has been designed for towing behind a swimmer. These swimmers may be discharged through torpedo tubes of submerged submarines, or they may be dropped overboard close to shore and would tow the tank to a point near the beach. While this test tank was manually operated, future developments will provide a time delay and automatic release of the spray while the swimmer escapes. Under the right weather conditions, the aerosol would be carried inland over the proposed amphibious attack area. Plans for amphibious operations would, of course, take into consideration the incubation period of the biological agent. The Navy has given considerable attention to the dissemination of agents from the air. Any Navy or Marine plane that can carry a bomb can be provided with spray equipment. The auxiliary fuel tanks on attack-type aircraft can be converted to anti-crop spray tanks by adding an electric pump, a nozzle, and a venturi. This assembly has been designated the Aero X2A spray equipment. Anti-crop spray from aircraft using the Aero X2A has proved very effective in field trials. Another development has been the design of the Aero X14A all-purpose spray tank. This tank can be used for disseminating all types of agents. Extensive tests using the F-7F as the carrier have shown that it works especially well at high speeds and can be used on jet aircraft such as the F-9F Panther, the F-2H Banshee, and other future planes of this type. For larger planes, the Air Force has perfected spray equipment. This B-17 has several spraying nozzles and carries the tank in the bomb bay. The same equipment has been installed in a C-47 and has performed satisfactorily. The equipment is such that it can be installed in any plane with a bomb bay, such as the Navy's P-2V or similar land-based planes or flying boats. Is the first model of an air-launched missile developed by the Navy specifically for biological or chemical warfare. Called the Gorgon 5, it's a programmed preset missile with guiding mechanism mounted in the nose. An Aero 14A tank will be mounted here in the midsection. Spraying will be through an internal pipe from the tail section, which also contains the control surfaces and operating mechanisms. Fully loaded, the missile weighs 2,400 pounds and can be flown from the deck of a carrier. When released, the missile will follow a glide path of about 15 degrees to a predetermined low altitude where it will automatically level out and spray at a preset position. Launched from a carrier several hundred miles at sea, planes carrying the Gorgon 5s would approach at about 35,000 feet and release their missiles about 20 miles from the target. This altitude minimizes interception and the range is well beyond anti-aircraft fire. The Gorgon 5s would then glide to the target and automatically spray their contents over the predetermined area before destroying themselves. Another weapon that is also being considered is the Regulus. It is a long-range guided missile, surface-launched, jet-propelled, and electronically guided. Launched from a submarine or a ship at sea, this missile would fly a tank of agent over the target area and automatically disseminate it. Regulus is still in the developmental stage, and its adaptation to biological and chemical warfare is something for the future. At present, the Navy's plans for the use of projectiles for this type of warfare are confined to dispersion of chemical agents. For its ships, the Navy has or will have a variety of gas-filled projectiles. The 5-inch 38 caliber, the 5-inch 54, the 6-inch 47, the 8-inch 55, and the 5-inch spin-stabilized rocket. In addition, the Marines now have chemical munitions for the 4.2-inch mortar, the 155mm howitzer, and the 105mm howitzer. Within the near future, they will have chemical munitions for the 155mm gun and the 4.5-inch rocket. We have seen what the Navy will be able to do in waging biological and chemical warfare. We'll now see how the Navy plans to defend itself against this type of attack. The Navy's defense includes the standard defensive measures against air and surface attack. In addition, the Navy will provide its own combat personnel with protection available to the joint services, such as protective clothing, gas masks, and immunization. Some of the special protective devices developed by the Navy, which can be used for biological and chemical defense, are the ship's water curtain or shower bath to minimize contamination by washing deadly agents overboard as soon as the spray touches the ship's surfaces. An electrostatic precipitator cleans contaminated air by passing it through a charged field and depositing the charged infectious particles onto grounded plates, resulting in clean air. At sea, of course, the mobility and maneuverability of the Navy's ships, under the command of its experienced and well-trained personnel, is one of the Navy's best defenses against biological or chemical attack. The Navy's plans and programs are directed toward the goal of attaining at the earliest possible date an adequate defense, and to be ready to strike back with the most powerful counterattack that the Navy is capable of delivering from the air, from the sea, from under the sea, and from Marine forces ashore.